I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture number 12, we'll briefly discuss about types of task environments. The task environments in artificial intelligence refer to the specific contexts in which AI agents operate and solve problems. These environments vary based on factors like observability, dynamics, and complexity, influencing how agents are designed and the strategies they employ. Understanding the different types of environments, such as fully observable versus partially observable, deterministic versus stochastic, and static versus dynamic, is essential for creating effective AI systems. In this presentation, we will explore these different types and discuss how they shape the design and performance of AI agents in real world applications. We'll see one by one. First, we'll see, before going into the type, we'll see the nature of environments in AI and what is a task environment. A task environment refers to the specific problem or set of problems that an AI agent is designed to address. It defines the context in which the agent operates and outlines the conditions under which the agent must perform its task. The environment provides the framework within which the agent must navigate, make decisions, and act to achieve its objectives. And the challenges the agent faces are the task environment presents a set of challenges that the AI agent must overcome in order to succeed. These challenges can vary greatly depending on the environment's complexity, such as limited information, dynamic changes, or unpredictable outcomes. For example, in a partially observable environment, the agent may struggle with the incomplete data, requiring requiring it to make decisions based on uncertainty. Next, the tools and techniques needed to solve the problems are the environment influences the tools and techniques an AI agent uses to tackle the problems. Suppose if you are taking the fully observable deterministic environment, simpler algorithms might be sufficient, while in a dynamic or partially observable environment, more advanced techniques like machine learning, reinforcement learning, or probabilistic reasoning might be necessary to adopt and make decisions effectively. And the key insights are the characteristics of the environment shape the agent's design. The design of an AI agent is directly influenced by the nature of task environment. For example, an agent designed for a game like chess will have a different design and a decision making process compared to an autonomous vehicle navigating a real world city. Understanding the environment is critical because it dictates how the agent perceives the world, interacts with it, and ultimately solves the problem at hand. Next, we'll see the different types of task environment. The first type is fully observable versus partially observable. In a fully observable environment, the agent has complete access to the environment state at all times. This means the agent can observe every aspect of environment, allowing it to make fully informed decisions based on the available data. This type of environment simplifies decision making because the agent does not have to deal with the uncertainty or incomplete information. And examples, if you are taking puzzle games, if you are taking the puzzle games, what is happening in the puzzle game? In puzzle games like Sudoku or crossword, no puzzles, the agent can see the entire game board or puzzles at all times, enabling it to make decisions based on the full set of available information. Without the full set, we cannot go for the final decision. The next example is the tic-tac-toe, and in this case, what we are doing it, all the squares and values on the game board are visible, allowing the agent to easily determine the best move by considering all possible states of the game. The third example is the image analysis. In this case, in image recognition task, the agent has access to every pixel in an image, allowing it to process and analyze the image in its entity entirely without missing any details. And the next type is the partially observable. In this case, in a partially observable environment, the agent has incomplete or noisy information about the environment. This means the agent must make decisions based on limited data, often requiring it to infer missing information or predict unknown elements. Handling uncertainty and making decisions with incomplete knowledge is a core challenge in partially observable environments. Example, if you are taking the example poker, in poker the agent cannot see the opponent's hidden cards, so it must rely on the visible information such as the cards on the table and the behavior of the other player to make strategic decisions. Next example is the interactive science tutor. An interactive science tutor may only have access to the student's input such as answer or questions, and must make decisions and provide guidance based on the limited information. The third example is the military planning. In this case, military planning, agents and strategic often have limited information about enemy movements, requiring them to make decisions based on incomplete intelligence or predictions about the opponent's actions. So, if you are taking this fully observable and partially observable, the distinction between fully and partially observable environments highlights the level of certainty or uncertainty the agent must navigate when making decisions. So the next type is the deterministic versus stochastic, and versus another one more type is the strategic. In a deterministic environment, the next state of the environment is entirely predicted based on the current state, right? At the and the agent's actions, there is no randomness or uncertainty involved in the transition from one state to another, allowing the agent to predict the outcomes of its actions with certainty. Next example, if we are taking the example for this case, image analysis, as I have said previously, in image processing, steps involved in analyzing an image follow a clear and predictable path, with each action, that is if you are taking the example feature extraction or classification leading to a specific outcomes. And another example, if you are taking tic-tac-toe, in this case, in tic-tac-toe the game state only changes when the player makes the move, and the outcome of the each move is fully predictable based on current configuration of the board, or board actually. Next one is the stochastic. In the stochastic environment involves randomness or uncertainty in the outcomes, meaning that even when complete knowledge of the current state, the agent cannot always predict the next state with certainty. This randomness requires the agent to consider probabilities and adapt to unexpected events. If you are taking the example car driving, when driving a car, outcomes depends on many factors, such as the behavior of the driver, weather condition, and road hazards, making the environment unpredictable and requiring the agent to make decisions based on probabilistic reasoning. The next example is the robotic firing in crowd. In scenarios like a robot firing in a crowd, the movement of the people, where they go, on unpredictable and random, making it difficult for the robot to anticipate exact outcomes. So the third type is the strategic. In the strategic environment, is the deterministic in nature, but it involves the action of other agents that introduce uncertainty. The environment itself is predictable, but the agent must account for the decisions and strategies of others, which can influence the outcome. Next one is the The example for this case is the strategic is this chess game. In chess, the game's environment is deterministic, but the agent must anticipate and react to the opponent's moves, making the games highly strategic and influenced by the actions of the other agents. And example, trading agents in financial market, the environments may follow the deterministic rules, but the actions of the other traders and market dynamics introduce a level of uncertainty requiring agents to predict and react to other strategies. These distinctions help define the complexity and decision making strategies an AI agent must adopt in different environments. The next type is the episodic versus sequential environment. In an episodic environment, each actions or decisions the agent makes is independent of the previous data, and each episode is self-contained. The agent's current action does not affect the future actions, meaning the problem can be broken down into separate in isolated episodes. This simplifies decision making because agent does not need to consider past states when making a decision. Example, if you are taking blood testing, each blood test is independent of others, meaning the decision making process for each test does not rely on the previous test. Each and every time, if you are taking the blood test, it will be different. The decision will be different. The results of one test do not influence the next. The next example is the defective part decision. In manufacturing, the decision to detect a defective part in one batch is independent of previous or future batches, making each decisions isolated and self-contained. Contained. Next type is the sequential. In a sequential environment, the agent's current actions influence further outcomes. The decisions made at each step build upon previous actions, creating a chain of events that must be considered when making future decisions. This type of environment requires the agent to plan and to think ahead as its actions have long term consequences. So, if you are taking the example, the chess game, in the chess, each move builds on the previous one, and the current board state directly influence what the further game state. The agent must consider both the immediate and the long-term effects of each move. Example, another example is the refinery controller. In refinery, the actions taken by the system at one point, such as adjusting temperature or pressure, affect the future states of the system. These decisions must be made carefully to avoid undesirable outcomes and ensure the system runs smoothly over time. These distinctions help define how an agent should approach problem solving with episodic environments allowing for simpler isolated decision making, and sequential environment require more complex and forward thinking strategies. Next, coming into the dynamic versus static versus dynamic. In a dynamic, semi-dynamic also we'll see. First, we'll see the static. In a static environment, the world does not change while the agent is deliberating or making decisions. The environment remains fixed until the agent acts, allowing the agent to plan and think without worrying about real-time changes. Example, if you are taking the crossword puzzle, the puzzle grid remains unchanged unless the agent makes a move, allowing the agent to analyze the puzzle without external change affecting its strategy. Example, another example is the 8 queen puzzle. The chessboard in the 8 queen puzzle remains static, and the agent can focus on finding solution without any changes in the environment. The next one is the dynamic. So in the dynamic environment, the environment changes continuously even while the agent is deliberating. This requires the agent to adopt its actions in real time as the environment evolves. Example, car driving. The traffic or road conditions or the weather conditions, weather continuously change, requiring the agent to constantly adjust its driving. That is why we are calling it as the dynamic. Boat driving, wind or waves alter the environment, making navigation unpredictable and requiring the agent to respond dynamically or to shifting conditions. Next, in semi dynamic environment, the semi environment, the environment itself does not change, but the agent's performance is time sensitive. The agent must act quickly to avoid losing opportunities for phasing penalties. Example, timer. The environment remains static, but the agent, that means a student, must complete task within a set of time, requiring prompt actions to avoid running out of time. These distinctions highlight how the agent must adjust its strategies based on the stability of or fluidity of its environment. Next one is this. What is that? Single, discrete versus continuous. That we have seen it. Next one is the discrete versus continuous. This we have no. You understood about the discrete versus continuous. Next is single agent versus multi-agent environment. In a single agent, only one agent interact with the environment. No, making decisions and taking actions independently. The agent's performance is determined by how well it navigates and interacts with the environments on its own. Example, maze solver. A single agent navigates through a maze, making decision at each step to find the exit. For example, another example is the boat driving. A single agent perceives its surroundings and acts to navigate the water, responding to environmental factors. Next, multi-agent. Next type is the multi-agent. Multi-agent environment. Multiple agents interact with each other, either working together, that is cooperatively, competing against each other, and are having opposing goals. The presence of multiple agent introduces additional complexity in decision making and strategy. Next, cooperate. Here the example, if you are taking three examples: cooperative, competitive, antagonistic. The first example, if you are taking cooperative environment, fantasy of the football, multiple agent players work toward a shared goal, such as maximizing the team performance in the game. Competitive example, competitive, if you are taking trading agents compete in financial market to maximizing individual gains, making decisions based on market data and the action of the other traders. Antagonistic example, the example is the war games. Teams or agents with opposing goals, that is, one side aiming to defeat the other, interact in a strategic environment, requiring each agent to anticipate and counter the actions of its opponents. These distinctions highlight the complexity of environments where agents act alone versus those where multiple agents interact either in harmony or opposition. The next type is the competitive versus collaborative AI environments. In competitive AI environment, agents work against each other, each striving to achieve its own goals at the expense of other. The agent strategic are designed to smart and defeat their opponents, often other optimization and learning. Example, Alpha Zero. An AI system that plays games like chess and Go using self-blade to improve its strategies and ultimately defeat its opponents by anticipating and countering their moves. Next, collaborative AI. In a collaborative AI environment, agents work together to achieve these shared goals. The agents coordinate their actions, share information, and collaborate to solve problems or optimize outcomes. So, examples, if you are taking autonomous vehicle, self-driving cars communicate with each other to avoid collisions, optimizing traffic flow and reduce travel time, working together to improve overall driving experience in smart cities. These environments showcase how AI agents can either compete for individual success or collaborate to achieve collective goals. The last type is the known versus unknown AI environments. In a known environment, all rules and states and outcomes are fully defined and understood, allowing the agent to have complete knowledge of how the environment operates. This predictability enables the agent to make decisions based on a clear understanding of the system. Example, if you are taking the chess, the rules of the game, possible moves, and outcomes are fully known, making it a predictable and structured environment where the agent can play it strategic accordingly. Next, unknown environment. In an unknown environment, the rules, states, or outcomes are not fully defined or understood, requiring the agent to explore and learn as it interacts with the environment. The agent must adapt to new, unforeseen conditions and making decisions based on the limited evolving information. So, example, if you are taking Mars rover, what we have sent to the, that is moon, the Mars rover. The rover encounters unknown terrains and environmental conditions on Mars, requiring it to adapt and learn in real time and to navigate and perform tasks effectively. These environments highlight the difference between predictable structured settings and structured settings and dynamic exploratory and situations where the agent must continuously learn. So, thank you. Thank you for your attention and participation in this presentation on AI task environments. We have explored the various types of environments that influence how AI agents interact with the world, from competitive and collaborative settings to known and unknown challenges. Understanding these environments is important for designing effective AI systems that can adapt to different problem solving scenarios. Hope all you have understood this lecture. The remaining things we'll discuss in the next lecture. Thank you once again.